Hello, students. So we are in chapter 7, and in the first section of chapter 7, we introduced the law of sines, and we began using it to solve triangles when given information about the triangles. We're going to continue to do this in 7.2, which we're going to look at now. And in 7.1, we looked at different cases of what information you're provided about a triangle, and then how you would solve the triangle using the law of sines from that information. And so looking at the first part of this, they began by in 7.1. From 7.1, we looked at case 1. And then in 7.2 now, we're going to look at case 2. And so I'm going to try to start with a little overview of how what we're doing in 7.2 is a little different than what we did in 7.1, and why we have a special case for that. So in case 1, we learned that we can solve a triangle. We can solve the triangle, meaning figure out all the sides and angles of the triangle, if we are given 3 bits of information about the triangle. And the ones we considered were, if I was given 2 sides of a triangle and the angle between them, which we described as side, angle, side, then we could use the law of sines to solve for the other 2 angles and the missing side. Or if instead we were given 2 angles from a triangle and the side that was between those 2 angles, which we write as angle, side, angle, then we could solve for the other parts of the triangle. Or if you are given all 3 side lengths of the triangle, well, you could imagine you just stick those 3 line segments together and you get a triangle. But we would still wonder, what is the angle? What are those 3 angles formed in that triangle? So we could still solve the triangle. And the other case that we considered was that possibly we were given 2 angles and 1 side, like angle, side, angle, but instead of having the side between the angles, the side was not. So that was angle, angle, side, or you could write it as side, angle, angle. And then in that case, we could also solve for the triangle. We could quickly find the missing angle, since we know 2 of them and they have to add up to 180, and then continue with the law of sines, etc. Now, in each of these cases, you could consider sometimes if the information provided was of a certain type, you could not make a triangle. So for example, let's take a simple case of side, side, side. If I give you 3 side lengths, well, we know in a triangle, any 2 of the sides have to add up to more than the 3rd. So if I gave you side lengths of 2 inches, 3 inches, and 10 inches, you could never make a triangle out of those, because sides 2 and 3 would never be able to connect to the 2 ends of the side length of 10 in a triangle, because they're not long enough. So there are sometimes a couple of, sort of extreme situations, or in each case of these, there's a possibility where maybe you couldn't actually make a triangle with the information provided. But most of the times, as long as it was feasible, you could make the triangle, and there was only 1 such possible triangle. So those were all lumped together into case 1. So in case 2, we're now going to consider this side, side angle. So like the side, angle, side from case 1, we are given 2 sides and an angle of the triangle. But in this case, the 2 sides, the angle's not between the 2 sides, whereas in case 1 it was. So let's consider case 1 again with side, angle, side for a second. So if I know 1 side, we'll call it side A. I know the length of that side, and I know another side, side B, and I know the length of that side. and I know the angle that goes between them. So I have these, you can think of it as these two line segments, and I can attach them together because I know what angle at which they meet. We would label that angle C because it's opposite the missing side C that we don't know. So in this situation, if I put together these two line segments and I put them together at a specific angle, then I want to say, how could I make the rest of the triangle? Well, again, it's possible if the angle C was 180 degrees, then A and B are forming sort of a straight line, then you couldn't make a triangle. But as long as C is less than 180 degrees, then you will always be able to make one and only one triangle by just connecting the other two sides, the ends of A and B together to make the third side C. And there would only be one way to do that. And so there's only one triangle that you can make when you're given side angle side with the information provided. And the only way you wouldn't have a triangle is if angle C was 180 degrees. But as long as it's less than that, any lengths of A and B, you can just connect the other ends of those line segments and make a triangle. And that is unique. There's only one way to do that. So, however, what happens is if the angle you are given is not between the two sides, in the case that as in the case we just considered, things get a little bit more complicated. And that's why we have a separate case or a separate situation to consider when you're given side-side angle. We're still going to try to solve this using the law of sines and figure out what the possibilities are. And it will still be dependent on the sides and the angle we're given. It's possible with the two sides and the angle you're given, you just can't make a triangle, as we saw in some of the situations in case one. But it's also possible you might be able to make one triangle and only one, or maybe there's even two different possible triangles that could be made with the exact same size and angle that you were given. And we have to consider these different possibilities. So let's try to visualize a little bit about why that might be the case, and then we'll look at the methods to figure all this stuff out. So we have here a diagram, and we're going to try to consider a description of the ambiguous case, case 2, where we're given side and angle. And so what I'm going to point out is that they've put an A here, an angle A, and this is going to be the given angle. And so we're going to say this is the given angle because they're drawing these two line segments meeting at angle A here. They've got this little blue arrow between the two line segments, and they're saying that's the angle that these two meet at. So that's given, that means that's fixed. We don't get to change that. That's part of the information given. Also, the length of side B drawn in here is given. And so that means that it goes from the tip of one end to the tip of the other, and that cannot be changed, that cannot be adjusted. So we're just going to say that's one of the two sides that given. So the next bit of information that is given is another side length. And when we know that the angle that's given is not between the two sides, then it must be opposite one of the two sides. So when they're giving us angle A, that's because they're saying that it's opposite one of the sides that's given. So the other given side is angle A. So there's going to be some side A over here that is given, but what we're going to do is consider based on the length of that side and how it compares to side B and angle A, what kind of triangles could be formed. So they didn't draw it in yet, and we're going to consider the different possible ways that you could draw it in. So for example, the thing to keep in mind here is that in what's given just with side B's length and the fact that angle A is set, well, what that means is I cannot make B longer. Whoops. I cannot make B stops here where we're going to eventually form angle C, and we're going to draw side A off of that point. B stops there and it starts down where angle A is at the vertex. So that means I can't make angle B longer. Nope. I can't do that either. I can't make angle B, I can't make side B longer, and I can't make side B shorter. So I can't make that side stick out farther or come back and be shorter because side B is given and that's fixed. And because I can't change angle A, I can't move side B down in this direction or swing it up higher in that direction. Nope. I can't do any of these things. So the fixed angle A and the fixed side length B means that the end of side B up on the top there is going to hover over the bottom side, side C. So side C, we're going to set here as the base. Now, side B could be longer, sure. We don't know how long side C is going to be. It could be shorter. We don't know where it ends. So it could be more to the right or more to the left. That will be depending on where side A comes down. But ideally, somehow side A is going to come down and meet it. But we don't know. But that point at the top of the triangle that we're trying to make cannot be moved. It cannot be, that side cannot be lifted up or down. The side cannot be extended or pulled back in any way. And so what I'd like us to consider is then I can imagine that that point above the base has some fixed height. There's some height to the top where that point is, above the base. Now, one of the ways we could make a triangle is if A was the length of the height up to that point, then you would have this nice right triangle. So we're going to figure out the different ways we can make triangles. But however A comes into play, that point at the top of side B there has some fixed height. And we know that height because if it goes straight down to the base, that forms a right triangle. So we know that height is equal to the hypotenuse times sine of A. Again, that's because sine A is H over B. So that means H is equal to B times sine A. B is given. Sine A is given. So once you tell me how long B is and the angle that B lifts up off of the base, then I know where the top of side B finishes, and I know how far it is away from the base. That's the height if I were to drop a line straight down, and that's H. And that cannot be changed. No matter what they give us for side A, that information is fixed. So with this in mind, now let's consider the possibilities based on the length of A. So there's this H distance here that cannot be changed. So let's say that the A value that's given for side A, the length of side A, ends up being less than this H value. So A is coming down off of C, but it doesn't go as far as H. Maybe it goes this way. Maybe it goes straight down. Maybe it goes that way. But if it's less than length H, well, then it will never reach down to the base, C, because I can't lower it down. I can't lower its starting point down. The vertex between sides A and B at angle C cannot be lowered close to side C. And so if A isn't long enough to reach down there and touch side C, there's no triangle. So let me basically we're just going to put that over here. So A being less than H, which is equal to B times sine A, based on B and A, means no triangle. And as we said in the earlier cases, case 1 situations, sometimes there's no triangle. It's certainly possible that there's no triangle. All right, so that means to have a chance at forming a triangle with the information provided, we need side A to be at least as long as H. So let's use that as our second possibility. So let's say that A is equal to H. It's equal to B times sine theta. I'm sorry, sine A, not sine theta. Well, if that's the case, then A is the same length as H. And so if it's in a triangle, it exactly shoots straight down and just barely is able to touch the base length. And if that's the case, then this could be side length C, which is unknown, but you could form a triangle with that B, with that A length, and with angle A. You can make a triangle, but only the one where you have a right triangle. Because if you didn't have a 90-degree angle where A meets C at angle B there, if you didn't have a 90-degree angle, then you wouldn't reach down to the base and you wouldn't be able to make a triangle. So if you're given angle A, side B, and side A, and side A is equal to B times sine of A, which would be the height that you would need it to be, then you can make a triangle and you can solve a triangle, but only one would be possible. So that would mean that there's one possible triangle in that situation. So then the next thing we might consider is that A is actually larger than H. What if A is longer than H? Well, if A is longer than H, then obviously if I went straight down, I would not be able to get a triangle because side A would be passing past the base. So let me erase this and put us in our situation again here. So if I have this H value, which is the distance straight down to the bottom, that's H. But if C is longer than H, well, as it gets a little longer than H, how might I make a triangle? Well, I might make a triangle by going to the left or to the right a little bit, which allows me to make A a little longer. That depends on the length of A. But if I have A value that's longer than H, maybe I could swing over to the right so I can still make a triangle with that longer than H side length, or maybe I could swing to the left. And if it gets even longer, I would have to swing farther to the left or farther to the right to still be able to make that triangle. So maybe A is over here, or maybe A is over here. And of course, C is not fixed, so we can make C the correct length and we can still create a triangle with those side lengths given. But I'm not able to swing A to the left unless A is less than B. So for example, if we look at this most extreme triangle that I've drawn here, all the way on the edge, as A gets longer and I'm trying to draw it to the left here, well, it needs to stay less than B in order to fit in this little window of opportunity. As it gets longer and longer and it pushes over closer to B, if it actually became the length of B, well, then I couldn't draw it on the left. I could still draw it on the right, but I couldn't draw it on the left. So the situation we're considering in this case now is that the A value that's given is greater than H. So if H is less than A, but A still stays less than B, well, then in that case, the A side could be drawn sort of to the left coming down from the top or to the right coming down from the top. So in that case, that means there's two possible triangles. Two triangles that could be made. And then the final situation to consider is that A got to the point where you can't draw it to the left because it's the same length as B or larger. If it was the same length as B, then as I draw it to the right, I could have a nice isosceles triangle where both of the top two sides, A and B, were both the same length. But I couldn't draw it to the left because it would sort of land right on top of B as I tried to draw the line. So if A is greater than or equal to B, then the only way I can draw that side, let's take all this stuff out. If A is greater than or equal to B, then the only way I can draw side A is to swing it out to the right. And then it could be as large as we want. It could be very, very large, off to infinity, really. By just making C longer, then we could have C go out and meet wherever A landed on the base. And then we could make a triangle that way. But so if A is larger than or equal to B, then we have to go out to the right. And that means that we also can only have one triangle. So it really depends on the side lengths given and the angle given. But depending on what's given, the possibilities are that there's no triangle that can be produced. So maybe there's no triangle that can be produced, and that would happen if the A length is less than B times sine of angle A. The other possibility is that you have one triangle. That would happen if A is equal to B times sine of angle A, or if A is greater than or equal to side length B. In either of those possibilities, there's only one triangle that could be formed, and then we could make it and solve for that triangle. However, if side length A happens to be less than side length B that was given, but more than B times sine of angle A that's given, then there are two possible triangles that can be formed. One where you have sort of a triangle that looks like that, and one where you have a triangle that looks like that. So one of them, it has an interior angle that's greater than 90 degrees. And one of them, all three angles in the triangle are less than 90 degrees. And those will be the two possibilities. So I tried to sort of help us visually understand this by thinking about the dynamics of what's provided and how you could construct a triangle. And they now have a summary slide for these possibilities. And so I think this helps. They kind of just draw out the four possibilities that we just showed, and they give the situation about A applying on the right, in which we have A is between, well, different things. So if A is less than the height that would be needed for it to get down to the base, then there's going to be no triangle. If A is equal to exactly the height to get down to the bottom, because it's equal to that direct distance down, then there will only be that one possible triangle. If it's larger than B, then there's only one triangle, or equal to B. And then lastly, if it happens to fall between the height and the B side length, then there's two possible triangles. And they have this nice little thing to summarize that. And you can try to envision these different possibilities. Now, when we are just given a side and an angle, then we don't know which of these situations is the case. I mean, you can look at you will know the angle, which side it's opposite by how they're labeled. Like if you label this angle A, and then you would know it's opposite side A. So you'll know which side you're talking about. So the key thing here is what I'm talking about, side A. It's the side length that's opposite whatever angle they give us, whatever letter that is. So if they gave us angle B and they gave us sides B and C, then everything we just described here, we'd be talking about side length B compared to side length C, instead of using the letters that we have here. So the key thing is that when they're talking about A, it's because they gave us angle A. So we have to consider what angle they gave us and what side that's opposite. But once they provide this information, how do we know which of these three situations is the one that's involved here? Well, we're going to apply the law of sines to help us choose between which situation is possible and how many triangles we can or cannot make. And we'll just do that in examples to try to illustrate how that works. But we want to have these ideas in mind because that guides our use of the results when we're applying law of sines to try to figure things out. So the other possibility, now these were all assuming that A was acute, and I drew the picture initially that A is an acute angle. If A is obtuse, and then they consider those two possibilities, meaning that it's larger than 90 degrees, well, then there's only two possible outcomes. A has to be longer than B in order to get down past that wider than 90 degree angle and reach the base. And if it's not large enough, if it's less than or equal to B, no triangle. And if it's longer than B, then yeah, then you can make a triangle, and the length of C will be determined by where A happens to land on the base. So those are pretty simpler because you can just look at that directly. You can just look right away and say, okay, well, look, the angle they give us is more than 90 degrees. So we need the side opposite that angle to be basically the largest side in the triangle. So it needs to be bigger than B. Anytime you have a triangle where one of the angles is more than 90 degrees, well, the side opposite that has to be the biggest side in the triangle or you can't make a triangle. And so there's a quick way to sort of imagine you could check that in that case. So this one's not as complicated and it's easy to spot because the angle they give us will be greater than 90 degrees. The complicated situation is when you have an acute angle and then there's different possibilities. All right, so that's a lot to think about. So let's look at some procedure. Let's see how we try to apply this. So they try to map out the idea and then we'll look at some examples. So for any angle theta of a triangle, we know that sine of theta is between 0 and 1 because the angle is going to be between 0 and 180 degrees and all sine values are between 0 and 1 in those cases. And if sine is equal to 1, then we know the angle is 90 degrees and the triangle is a right triangle. So that's something to keep in mind. Anyway, so they have some of these properties like this. One of the ones I want to mention here, because it relates to the obtuse angle we just talked about, is this one. Let's look at number 3 here. The smallest angle is opposite the shortest side. The largest angle is opposite the longest side. And the middle value angle is opposite the intermediate side. Assuming that, you don't have two angles and two sides that are the same. And if they are, then those will be equal as well. And so that helped us in the situation here, where if A is bigger than 90 degrees, then angle A has to be the largest side. And if you are given that B is larger than A, you can't make a triangle. Simple as that. All right, so let's look at some example case here. So they're telling us in advance to help us sort of understand the thought process that in this first example, there's going to be no such triangle that we can make. And so let's remind ourselves of what that looked like, because as you're just looking at a pile of numbers and calculations, it's hard to visualize that. So the case where no such triangle could be made was if angle A was acute, it's because the side A length given opposite that angle was not long enough. It wasn't as big as H, and that meant that it wasn't as big as B times sine of A. If it was obtuse, well, then it's just not larger than B. So looking at the angle they're giving us angle B. They're giving us angle B. And we can see that it's not, it's an acute angle. So we have the first situation where there's different possibilities. So that means the angle B is opposite side B. And so in the triangle, I would be putting B down in the corner here. And I would be imagining side B would be up here. And the other side they gave us was A. So actually side A is over here. And so we need B to be long enough to get down to the bottom there. We need B to be greater than or equal to A times sine of angle B. If it's equal to A sine B, well, then we get a right triangle. If it's greater than A sine B, we might get two triangles or one triangle. But if it's shorter than A sine B, we can't make a triangle. Now, you don't have to look at that directly. In each of these problems, you can just jump right in and go to the law of sines. So when you are given two sides and an angle opposite one of those, you're going to get 3 of these 4 from the law of sines right away. And you can always just jump right in and plug in the 3 that you're given. So in this case, we're given 2 sides and an angle, as we will. And so we will be solving for another angle. So when we go to solve this, you're going to get sine of A, you don't know, and then you're going to have 3 things that you do know. So you isolate sine of A, and then you say, all right, to find angle A, sine of A has to be equal to this number here. But what will happen when no triangle is possible is that the value you get for sine of A can't be achieved with an angle A, in this case, because it's larger than 1. So as they show here, when you try to use the law of sines, the thing that tells you that no triangle is possible is that you get an equation to try to solve for angle A that has no solution. If you get sine of A is supposed to be equal to 2 something, well, there's no angle that's going to make the sine do that because the maximum value of sine is 1. So since in this case, since sine of A needs to be greater than 1 and that's impossible, no such triangle exists. So that hopefully will be something that makes sense right away. You just have to be prepared that when you're using the law of sines to try to solve for the triangle, when you're given side-side angle, it's quite possible you'll try to solve for an angle and it's not, there's no solution available. And that means there was no triangle possible. And so they're helping us visualize that. This was because the B length that was given was not long enough to get down to the base and form a triangle. With the angle that was fixed and with the hypotenuse angle side length there, A of 25.1, the B length just wasn't long enough to come down and make a triangle, which is the first diagrams that we drew. So I'm glad that they sort of help us visualize why we fail to make a triangle with the information provided for the 2 sides of the angle. And so it's pointing out in the ambiguous case, we are given 2 sides and an angle opposite one of the sides. As we saw, that's side-side angle. That's always going to be what we're given. If we're given one of the other configurations that we dealt with in case 1, well, then it may be that there's no triangle, but usually there is, and there's only one, and you can solve for it directly. All right, so then let's look at the interesting case where 2 triangles are possible. And again, when you first are given an angle and a side, you can take note that the angle is opposite one of those sides. And so then you can imagine the little setup, and you don't have to draw it, but I do find it helps students to do this. So we're given angle A, so I'm going to call that A. And so the side that's opposite A is the one that's going to drop from the top. That's the A value given. And we're given B is 24.9. So for example, I can see that A is 22.8. That's less than B. And as long as it's long enough to get down to the base, which would be at least as much as needed to get down there, which we saw, if it's too short, you can't do that. But as long as it's long enough to get down to the base, you can make 2 triangles because it's not longer than B. So that means it either goes straight down and it makes 1, or if it's longer than that, then it goes to the left or to the right, and there's 2 possibilities. So that's what's going on. Now, you don't have to visualize that up front, but I think it helps just by looking at the angle and the sides that are provided. We can just set up the law of sines. We're just going to do this each time, which makes things simpler as a way to start. And then we're going to know 3 of these. The only thing we don't know here is angle B. We know length A, we know length B, we know angle A, we don't know angle B, so we're solving for sine B. So they do that. And when they solve for sine B and plug in the parts they know, they did get a number that is within the range values of sine. And that means that this could work. Now remember, if sine B turned out equal to 1, well, then that tells you that we have a 90-degree triangle. But in any event, so in this case, we get this value for sine B. And so if you solve this using the inverse sine, you would get the smaller or acute angle. You would get the angle on the right by making the side go out to the right. You would get this angle here. So what we then want to remember is that on the sine function between 0 and 180 degrees, when you get a particular value, in this case about 64 degrees to get an answer, that's going to always be to the left of 90 degrees because the inverse sine function is going to give you some value over here. So here's where our 64 degrees is. So then that's one answer, but we want to get the answer that matches with that that's over on the right as well. That will be the angle over to the left on the triangle. And so how do we get that? Well, if it's 64 degrees in from the left, then by symmetry, the one on the right will be 64 degrees back from 180 degrees. And so they do that by subtracting from 180 degrees the first angle that they got. And that's how we get the second angle. So this is angle number 1, and this is angle number 2. And you may just try to memorize this, but again, it gets hard to memorize everything if you don't understand what's going on. And so the way we get the second angle in the sine function is take the smaller angle, subtract it from 180, and you get the bigger angle. And so that's then shows us that we could make triangles 2 different ways. One where we swung side A out to the right, and then this angle turned out to be 64 degrees, or one where we swung the side A down to the left, and that bigger angle on the inside turned out to be 116 degrees approximately. So now we do want to sort of make a check. I've been checking by drawing a picture, but they're just saying if we're just finding these 2 possible angles, we want to make a check that they're possible. And so they say, all right, well, this angle we got for this larger angle, this B sub 2, that we got as a possibility was 116 degrees, basically. If we add that to the given angle A here, we can see, oh, all right, we do get 2 angles that would fit within a triangle. And that means the other third angle could, in this case, be about 9 degrees, and that would make a triangle. And so that means that this larger angle we got is a valid possibility. If it ended up being too large, that would mean that we had swung out too far to the left and that inside triangle is not possible, and we have to go to the right, which would be B sub 1. So solving separately for these 2 possible triangles, one where we use B sub 1 and get a corresponding angle C sub 1, the smaller angle, and one where we use B sub 2 and get the corresponding C sub 2 angle. That will allow us to get those 2 different triangles, and we know the angles have to add up to 180 degrees. And so they take the information we now know, assuming the smaller angle, and they say, all right, well, then we can solve for C, and that means that would leave C being about 61 degrees. And then if we know A and B and C, and we were given sides A and B, we can find side C in the end using the law of sines again. And that would give us all of the triangle solved for. And then, of course, we can do the same thing. Let's see if they do it here. Yeah, so then the second triangle would be using the larger angle, B sub 2. And then, as I just mentioned a minute ago, if that was the case, then it turns out that that third angle would be about 9 degrees. And so they solve for that third angle and then use the law of sines with that third angle to find the last side, which would be pretty short in this case. And so then we have 2 different triangles, and they're showing them here in a nice diagram. So one was B sub 1 was where we swung this length A 22.8 length side out to the right and dropped it down to the base. And the other one was where we swung that same A length of 22.8 to the left and dropped it down to the base. And if we swung it to the left, we got a short little base. And if we swung it to the right, we got a larger base. So that's probably the more complicated of the situations where there's actually 2 different possibilities. And again, the simplest way to have avoided this feeling that there might be 2 was to observe that if A was less than B, if A, I'm sorry, was more than B, you can't swing it to the left, you can only swing it to the right. So basically, we're just going to always start with the law of sines. We're always going to begin with the law of sines. And if you do that and you end up trying to solve for the angle, which you're always trying to do in the first step, and you get something bigger than 1, then you can't make a triangle. If you're solving for the angle and you end up setting it equal to 1, then you get the 1 triangle because the side length drops straight down and forms a nice 90-degree triangle. If it's between 0 and 1, then there's one of 2 possibilities. it's within a range where you can get two triangles, or I would just say that if you look at side A and see it's bigger than side B, then you can only get one triangle. But if you're solving before you do that, then as you see, you can also check that, because you'll get two possible angles that could be formed there. And if one of them doesn't allow you to make a triangle because it's too big to fit in a triangle, that meant that you have to swing it out to the right instead of to the left, and you throw away the one that doesn't work. All right, so here's a one case example. So what are we given? We are given angle A, side A, that's the one hanging down, and side C. And again, these are just arbitrary letters, so it's not really crucial, but I could again try to visualize that. I'm given angle A, so I just usually always put that in the bottom left, which was our default in all these diagrams. And we're given the opposite angle on the opposite side to that. So I know that A is hanging down over here and it's 10.7. I'm just drawing it short, but maybe that goes down to the base, maybe not, I don't know. And I'm given angle C, I'm given side C, which is 7.2. So in this case, I didn't draw it to scale, but notice A is larger than C. So that immediately tells me I can't go straight down. I can't go to the left. I have to go out to the right to be able to go out 10.7 and hit the base. So there's one triangle in which I can do that. And I just observed that because A, the side that was opposite the angle given, was larger than the other side given. Now, again, you don't have to see that in advance. You can just, as with all these problems, just formulaically begin with the law of sines with the 3 of the 4 bits of information that you're provided. And in this case, it will be trying to solve for angle C. And when you try to do that, you get this value for angle for C. And when you solve with the inverse sine of that, you just get one possibility. You just get this 27.6 degrees because we're using the inverse sine. But what happens when you try to get the other possibility by subtracting this from 180, you'll get this bigger angle of 152 degrees. But notice 152 degrees, when added to the other angle you were given, 43.5 degrees, those add up to more than 180. So that second possibility is too big to make a triangle. That means I can't swing that side over to the left because it's too long. It will not make a triangle if I swing to the left. I have to swing it to the right. So it basically means you discard that. So then they say, well, and they sum it up here as I did in the beginning. Since C is less than A, C must have a measure less than A. So you have to swing it out to the right. And then you make that one triangle. And then once you know that that angle is the only one that's possible, you find the missing angle, and then you do law of sines one more time to find the last missing side. And then you get this triangle that's shown here. So lastly, what if we had an obtuse angle? So we looked at all of the different situations where you have an acute angle given. So in this case, they're giving us an obtuse angle. That means with an obtuse angle, it's simply whether the sides are able to make a triangle or not. So then you could imagine immediately drawing A, well, that was bad, drawing A with a very wide angle instead of with an acute angle. And so this is A. And so then that is the opposite to A is 26.8 meters and B is 31.3. So again, A is going to be over here and B is 31.3. Well, if A, little side A, is going to make a triangle, it can't be less than 31.3 with this big angle in order to get back to the base. And the A that they gave us is 26.8. It's not long enough. So because A is an obtuse angle, it must be the largest angle in the triangle. And thus A must be the longest side of the triangle. But in this case, A is less than B, so no such triangle exists. Now, does one more slide allow us to make a triangle? No. So if it wasn't the case, if A, side A was larger than side B, then you could make a triangle and you would do the law of sines to solve for that triangle as we did in the earlier examples. So that's it for 7.2. There's a lot in here, a lot of different situations to go through, but at least the process kind of stays the same. You jump right in with the law of sines and understanding the different possibilities when you have side-side angle gives you the ability to sort out the results that you may encounter when you're solving with the law of sines. So in cases 1 and case 2, we always can start with the law of sines. The law of sines is very powerful in all of these cases, but we do want to observe that if you have a side-side angle situation, if you're given an angle that is opposite one of two sides that you're also given, you have to be ready for these different possibilities so that you can solve what's going on correctly. Keep up the hard work. Hopefully this will give you what you need to do the problems from 7.2, and I'll see you next time.